So in this first video, I'm going to show you, for this first problem, how to use Google Sheets to calculate each of these things right here. So this corresponds over here to the computer calculations column for mean, median, maximum, minimum, interquartile range, population standard deviation, sample standard deviation, all that right here. Let's first take a look at the data set that we're going to be working with. So this data set is just a pared down version of the call center requests that were submitted. So we explored that data set a little bit a couple weeks ago. All I included here are only the requests that were submitted during April of this past year. Also, I only included the ones where they were marked as closed, so there was something completed about the ticket. And then I took out a whole bunch of the data just so it's simpler. All we really want is this list of numbers here to play around with and do calculations with. And so what I have is just the description of what the problem was, and then the category that it was in, and then how many days it took from when the ticket was open, when it was submitted, to when somebody at the call center marked it as closed. So this is 8 days to close, 24 days to close, 1 day to close, so on and so forth. So the really nice thing about Google Sheets is that all you have to do is know what commands to type. So I'm going to show you what those are, and then it will do it all for you. You don't have to get out the calculator. You don't have to do 6,000 different calculations. Because if we look back here at our data set, there are, if we scroll down here, 3,324, actually it's 3,323 because the first one's a header, different requests that were submitted and closed in April. So we really don't want to do that by hand. So I'm going to show you what to do. For mean, we just have to know what this formula is. So it is equals, and then open a parenthesis, and then type average. And you'll notice that it will say numerical average value in a data set. It doesn't say mean for whatever reason, it just says average, but that works. And what it is it will just give you the average of a range of values. So the range of values that I want is over here. It's this days to close. And so what I want to do is I want to select all of these numbers. So I start off at 8, and then I scroll all the way down, click Shift, and it'll highlight that entire thing. It's also a little bit faster if all that is in a column is what you want. You can also just click the column at the top, and it'll highlight that entire column, and it'll calculate the average of all of that. So if I do that, then you see I put in this last parenthesis here, hit Enter, and voila. Back on this first tab, there is the mean number of days to close a ticket. Make sure as you do this that you're writing down the formula in your notes so that you can refer back to it. It's right up here. I know people are also confused about the interpretation, so I'll show you how I would do that calculation and then interpret it. It's really important to be able to interpret whatever you've calculated, because just a number, like, who knows what that number even means. So in this case, the interpretation for me is we would say on average, it took 5.68, 2 places after the decimal is fine for rounding, days to close a ticket. That's the idea. I'm just going to show you the formula interpretation for the rest of them, and that'll be it for this lesson. So median equals median, logically enough, parenthesis, then do the same thing. We click on our data tab, highlight column C, close that parenthesis, there we go. Our interpretation, half of tickets took more than 3 days to close, half took less than 3 days. Maximum equals max, straightforward enough, click it. The longest it took to close a ticket was 57 days. Same idea for minima. Equals minimum. The shortest it took to close a ticket was 0 days. And this should make us a little bit suspicious. Nothing gets fixed in 0 days, so we might wonder a little bit about what this whole closing a ticket thing means. Okay, now we're into the slightly more complicated ones. First quartile, third quartile, interquartile range. If you don't know what these two things are, these are the two things that are used to calculate the interquartile range, you need to watch this video over here at Khan Academy so that you understand how to calculate it by hand. That's really, 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 really important because here, if you're just calculating stuff without knowing what it is, it doesn't do you any good. So remember what the first quartile is. So just like the median was the middle number of the whole data set, the first quartile is the middle number of the bottom half of the data. The third quartile is the middle number of the top half of the data. So the quartiles actually have their own formula, equals quartile. And then we select our data again. And now notice that there's a little bit more of a complicated thing. It's not just the data and then close parenthesis. We have to say what quartile it is. The quartile basically says what fourth of the data it is. So the 0th quartile is the minimum. The first quartile is the middle of the first half of the data. The second quartile is the median. The third quartile is the middle of the top half of the data. And the fourth quartile is the maximum of the data set. So if I just put in quartile 1, that's going to give me the first quartile. And there we go. So this is the middle of the bottom half of the data is 1 day, and I'll scoot that over so you can see it. It's 1 day to close a ticket. Then I'm going to do the same thing with the third quartile. So select my data. This time I want the third quartile. And the reason that we want this is because the interquartile range tells me, okay, what was the range of the middle of the data set? So here I can see that the maximum was 57 days, the minimum was 0 days. But I don't know, just from looking at the longest time to close and the shortest time to close, if that means that the data was evenly spread out. So did I have a lot of them that were like 47, 30, like that kind of a thing? Or was the data sort of more bunched up? And what I see looking here is I see that 50% of the data, so from the 25th percentile or the first quartile to the 75th percentile or the third quartile, that this was much, much more close together. So that 50% of the data fell between 1 day and 5 days. So this 57 is really, really far away. It's going to be what's called an outlier. And this kind of makes sense because I see like the median was 3 days. And then, it sort of looks like most of the data is between like, 1, 3, 5 days, somewhere around there. That's what this interquartile range is for. We would say the interquartile range, it doesn't have a formula itself, but it's just going to be the third quartile minus the first quartile. And again, if that's not making sense, you need to go and watch this video in Khan Academy to understand it. So the way that we would interpret that, we would say the middle 50% of the data, actually let's say the middle 50% of the tickets were closed between 1 day and 5 days after they were generated. The middle 50%, so this 1 and 5 days is interpreting the first quartile and the third quartile. The middle 50% of the data has a range of 4 days. Finally, standard deviation. This is one where it's really nice to have Google Sheets. Standard dev. So this is this STD EV. That is the sample standard deviation, the one that just says stdev. Again, I click data, edit it, it tells me that. So this tells me that on average, the values in the sample were 8.24 days away from the mean. And the population standard deviation, remember the difference here is that this is what we would use if we just had a sample of our data set, which is what we have here. A sample just means it's a subset, it's not all of the data. So we actually really wouldn't use this population standard deviation for this because we have a sample, but if we used it, it would be this standard dev P, standard deviation of an entire population. And again, click data, select it. There we go. In this case, they end up being very similar, but that wouldn't always be the case. So it only use if we had data for a whole population. But we would interpret it the same as the sample standard deviation.